A very good afternoon, everyone. Good afternoon. How are you? Welcome back to the class. All of you, welcome back to the class. This is Anirudh Mehta, your chemistry mentor. So this is our fourth class, as you can see. Up to now, we have completed few topics from the chapter mole concept. I have told you what are atoms, what are molecules, and what is matter in general. In last class, we started with just basics of how to write the mole concept. Okay, today we'll be dealing more with mole concept, and I told you how to do the unitary method, how to use unitary method. Just one small problem I told you. Today we'll be practicing all problems from the unitary method itself. Okay, so very good evening. We'll be starting in next 2 minutes. Okay. So let us see. You can all keep your hands away from the chat box so that you don't get disturbed. At 4:40, I'll switch on the chat. Okay, till then, please study very carefully and with full attention. So today we'll see what are the relations between moles, mass, volume, and number of molecules. So whenever you get any mole concept question, whenever you get a question like how many moles of CO2 contain these many atoms and so on, there are two ways to solve any problem. So any mole problem which is related to mass, atoms, molecules, or volume, there are two ways to solve. One way is unitary method that I told you yesterday. Today also I'll tell you each and every problem I will solve for you so that you get a more confident approach to mole concept. One way is unitary method, which I always follow. Okay, you will never ever go wrong when you use unitary method. Second way, which I don't generally like, is using the formula. There are few questions which are easier to solve using the formula, but unitary method works everywhere just fine. Okay, so let us start. First, I'll tell you some formulas to interconvert moles to mass or to volume or to number of molecules. Okay, let us make this flow chart. All of you keep your pens ready. Make this flow chart. And I'll make you understand how to go from mole to anywhere or how to go from anywhere to moles. Okay, so let's say they have given you volume and they ask you calculate the mass. Okay, volume to mass. You just think you have to go from volume to mass. Whenever you want to go from one place to another, you have to go through the center, means through the moles. Okay, so volume to moles you will go, moles to mass you will go. How to go? Just remember, whenever you want to convert moles into anything, moles to mass, moles to volume, moles to molecule, always multiply. So you can see here, when I want to go from moles to mass, I will multiply by molar mass. I am writing molar mass as mm. Okay, mm means molar mass of the substance. If they are talking about water, you will take 18 gram. If they talk about CO2, you will say 44 gram and so on. And whenever you want to come from anywhere to moles, you divide by the same thing. So when mass is given, you want to go to moles. Mass divided by molar mass is moles. First formula of the mole you got just now. Okay, first formula you got, remember it now. Moles, I will represent it by N, can be written as weight given by molar mass. So I'll write as weight of the substance by molar mass of the substance. Simple. Mass divided by molar mass, you will reach to moles. So moles are weight by molar mass. Simple. I will tell you to do all the questions by unitary method because that is much easier than this. But if you can learn, it's also good. Formula number 1. Second formula, let us relate moles with molecules. Okay, moles with molecules. When moles are given, we know that each mole contain Avogadro number of molecules. So when you multiply with Avogadro number, you can reach to molecules. You can reach to molecules. So moles multiplied by Avogadro number is molecules. Something like if I give you 5 mole of water, how many molecules? You will say 5 into Avogadro. 1 mole mein Na, 5 mole mein 5 Na molecules. And when molecules are given and I ask you how many moles are present, you will divide by Na. You will divide by Avogadro number. From here you get the second formula of your moles. Moles is given number of molecules by Avogadro number gives you moles. So that is the second formula. Moles can also be written as given number of molecules divided by Avogadro number. Call it as equation 2. Two formulas of moles I have just told you. Third formula of moles is when we relate it to volume of any gas. Okay, there is a law which is called as Avogadro's law. When you apply PV equal to nRT, the ideal gas equation, you will find that whenever you take 1 mole of any gas, okay, whenever you take 1 mole or Avogadro number molecules of any gas at STP, STP means standard temperature pressure, where temperature is 0 degrees Celsius, means 273 Kelvin, and pressure is 1 bar. Okay, whenever you take 1 mole of any gas at STP, please remember it occupies 22.4 liter always. Any ideal gas, 1 mole, whether it is hydrogen gas, whether it is CO2 gas, whether it is nitrogen gas, considering them to be ideal gases, a gas 1 mole always occupy 22.4 liter volume at STP condition. Correct? Please remember this term. We call it as molar volume. We call it as molar volume. We'll write about it in the next slide. So right now you can remember the number is 22.4 liter. So when moles are given, you want to go to volume. You will multiply with 22.4 liter. You will multiply with 22.4 liter. If volume is given, you will divide by 22.4 liter. Divide by 22.4 liter. Very simple, no? If I say 44.8 liter gas is given, 44 liter is given, how many moles are there? You will say, sir, 44 divided by 22, 2 moles are there. 1 mole occupy 22, 2 mole occupy 44. So this is the third formula that you have, which is moles can also be written as volume given at STP divided by 22.4 liter. Volume by 22.4 liter. This much also can be the volume. So volume must be given in liter, then only you will divide by 22.4 liter. So moles have 3 formulas for you now. Make sure that this third formula you only apply it to a gas, never to a liquid, because liquids do not follow PV equal to nRT. Mere bachche, liquids and solids do not follow PV equal to nRT. Their volume is not your concern. Okay, I'll tell you how to do the questions when volume of a liquid is also given, but not right now. So remember this formula is only valid for gases. Only valid for gases. So I just told you to remember 3 formulas if you can. Otherwise, unitary method works everywhere. The formula is mass versus volume, which is mass given by molar mass is moles. Mass by molar mass is moles. Second one, given molecules by Avogadro is moles. Okay. Third one is if it is a gas, given volume by 22.4 liter is also moles. I hope all of you are clear with this formula. Now we'll move to the next page and show you one sample problem. I have got you at least 10 to 12 problems today, all good problems according to NEET level. All of them are NEET level problems. You will not feel them to be very easy. Some of you might feel them to be difficult, but stay with me. I'll solve them. you understand how to do them. Okay. One sample problem let us do. So I'll show you how to do this problem with unitary method as well as with, the formula. Okay. Question is, calculate the number of molecules present in, calculate, all of you can write it down, calculate the number of molecules present in 560 kilogram of nitrogen gas at STP, or STP is not required, that is only the question. Calculate the number of molecules present in 560 kilogram of nitrogen gas. This is the very first question. I'll tell you both ways to do, whichever you feel is comfortable for you, you follow that way. Okay. I prefer to always do the question by unitary method, means writing the full mole concept. You see here everybody, I'll write the mole concept. Yesterday I told you how to write the mole concept. Mole concept means opening 1 mole of nitrogen and seeing whatever is there inside it. All of you see here. I am doing it by unitary method first. You should be very good with writing the mole concept. Right now I'll show you how to write the little bigger mole concept, but during a question you don't have to write the whole thing. You will write just the required things and get the answer. So I'll write the mole concept. I'll call it mole concept for what is given, nitrogen gas is given, no? So I'll write it for nitrogen gas. Mole concept will look like this. Always start by writing 1 mole nitrogen. I want to know what all things are present inside exactly 1 mole of nitrogen. Okay. As a thumb of rule, always write the mass, volume, molecules first. Mass, volume, molecule, simple. 1 mole means Avogadro molecules are present. Okay. 1 mole means 28 gram is the mass, because I told you yesterday that atomic mass of N is 14 AMU. So molar mass of N is 14, molar mass of N2 is 28 gram. Clear? Yes, sir. Now volume. We know 1 mole of any gas always occupy 22.4 liter volume at STP. Correct? Yes, sir. What else can I know? Now remember one more thing, 2 more things let me tell you now. Whenever you say 1 mole of any molecule, it's another synonym to say, another word for mole is gram atom or gram molecule. Gram atom or gram molecule. So, if I say 1 mole molecules of nitrogen, I can also say 1 gram molecule nitrogen. 1 gram molecule nitrogen. This means mole only. Don't think it is 1 gram as a mass. No, it's another name of a mole. Okay. For example, if I say from today, I'll call a dozen as a gram molecule also. A dozen can be called as a gram molecule also. So you will say, you will go to the market and you say, give me 2 gram molecules banana. So he'll give you 2 dozen banana. Okay. So another name of mole is gram molecule also. It can be called gram atom also if I was talking about an atom, but N2 is not an atom. No? So I'll say gram molecule. Okay. Clear? Let's keep it up to here. We don't have to know much more about it right now. So I told you for unitary method, whatever is known, you will keep it on left hand side. What is known? Mass is known. Mass is known. So I'll keep the mass on left hand side. I'll keep the molecules on right hand side. Mass on left hand side, molecules on right hand side. Or if you don't want to be confused with left side or right side, you can keep it anywhere and cross multiply. So I'll tell you what to do. So I'll keep, let's say, mass here and molecule data here. So my mole concept says that when mass is 28 gram, molecules are Avogadro. That's correct. Our mole concept says that when mass is 28 gram, molecules are Avogadro. Can you write like this? Yes, sir. Then our question says mass is 560 kg. So can I say 560,000 gram, units must be same. Then molecules will be how many? You keep X. Simple, keep X molecules. Now you have kept it left side, right side, not a problem. One side write the mass data, one side write the molecule data, and then cross multiply. What to do? Cross multiply. When mass is 28, molecules are Na. When mass is 560,000, molecules are X. Find X by cross multiplying. Done, cross multiplication done. So I get it as 28X equal to Na times 560,000. So X comes out to be, on the table of 28 ka double is 56, so it is going 20,000 times. So answer is 20,000 Na. 20,000 Na. I can open it up. I can say it is 20,000 into 6 into 10 power 23. Okay, 20,000 into 6 into 10 power 23. I'll keep all these zeros together. 1, 2, 3, 4. 4 zeros go there, become 10 to the power 27. 6 2s are 12. Always when you write any scientific notation, try to write it as 1.2 into 10 power 28 molecules. This is the answer. Okay, this is the answer. I hope it is clear to all of you how to use the unitary method. Keeping on left and right hand side, if you feel there is a problem, you can use this method also, crisscross method you can call it. Okay, this is unitary method only. So when molecules are Na, mass was 28. When molecules are X, mass is 560,000, cross multiply. And we get X as these many molecules. Okay. Second way to do this question was using the formula. To use the formula, I can write that there were two formulas we used. Let's compare the moles. I can say moles can be written in the form of weight as weight by molar mass, or moles can also be written as molecules by Avogadro number. Two formulas I told you. Two formulas of the moles. Moles can be written as given weight by molar mass, or moles could be written as molecules by Na. Can I say like this? I hope there is no problem in this. So I will say weight given is 560,000 gram. Molar mass is 28 gram. These are moles. Correct or not? 560,000 grams are given by 28 gram. These are moles. Moles can also be written in terms of molecules, which is given number of molecules. I don't know. I'll keep it X by Na. X by Avogadro. Cross multiply. You get X is equal to 20,000 Na. Okay. Whichever method you feel is comfortable for you, you go by that method. Okay. Unitary method will be much simpler. I'm just explaining to you. That's why it is little taking more time. But once you start doing the questions, see, the problem is with the use of formula, you'll be able to reach only from weight to molecules to volume. But when they ask you about atoms, electrons, or net charge, or number of subatomic particles, in that case unitary method has to be applied anyways. Okay, so in such small questions, your formula looks much simpler, but in the bigger questions, our unitary method will help us. I hope first question is clear to everyone. I'm moving to the next one. Okay, I'll move to the next question. All of you can write it down quickly, those who have not written, but please write along with me. Okay, I'll not be giving much time because class is very short and sweet, so we'll not waste much time. Okay, now I'll start with the second question. I want you to think about it, answer it in the chat box. I'll open the chat box for some time and just tell me if this question is clear to everyone or not. Just I'll open the chat box once. Please chat only with me, don't chat among yourselves. You are all good students, I know. You will respect your teacher, you will respect the class decorum, and you will maintain discipline as you always do, I know. Is this question clear to everyone? कल उसने रिफ्रेश किया तब आया था. Just a second, बच्चे. I hope this question is clear to everybody. Yes, now you can reply. Is this question clear to everybody? Yes, Thanu, yes, animates. Beta, unitary method will keep going on, don't worry. Yes. If unitary is not clear, do by crisscross. Crisscross is also unitary. It's just a simpler way. Okay, just a simpler way. All right. I'll be starting with the next one now. Next question. Let's move on to the next question. All of you solve this one yourself. I want you to solve yourself, everybody. Tell me the answer quickly. Formula looking easy, no problem, no problem. You will find unitary to be much easier. Okay, Satya, okay. First try to solve this. I'll tell you by unitary method also this one. Yes, yes, unitary will be very easy. Quickly do. Quickly do. Do this question. Malikiran, you might be joining the class little late, beta. Join the class on time. Okay, join the class on time. Okay, I'll give you 30 seconds to do the question. 30 seconds. That's the problem. Most of you are trying to answer little quickly. No, it's not correct. What you are answering is not correct, bache. Did you look at the units? Did you even look at the units? What B? Everyone is just shouting B. Did you look at the units? Sushila, Bhuvan, Karthik. Yes, only Thanu has said correct answer. And Manashri. Only Thanu and Manashri are correct. Yes. Now everyone is saying C. Don't do like this. You get chance only once. Okay? You get chance only once, not twice. They are talking about calculate the mass of 2.4 mole oxygen gas. Mole. Mole means so many molecules are there. That will be very heavy. Write the mole concept. See the unitary method. 1 mole oxygen. Oxygen gas means O2, not O. 1 mole O2 weighs 32 grams. I will not write the full mole concept. We require only this much. 1 mole O2 weighs 32 gram. 2.4 moles O2 weigh how much? That's all. Unitary method. 1 mole weigh 32 gram. I am using that crisscross method. Okay. I am comparing moles with weight. When mole is 1, weight is 32. When mole is 2.4, weight is X. Cross multiply. This is unitary only. Nothing else. Cross multiply. Okay. Is it clear, Manikant, now? Manikiran. So we'll say X equal to 2.4 times 32 gram. This is 32 gram. So answer is 76.8 gram, not AMU. Not AMU. Okay. Is it clear? 76.8 AMU is mass of 2.4 molecules of O2. Not moles. AMU is always used for single molecule. One molecule of oxygen is 32 AMU. Two molecules of oxygen are 64 AMU. 2.5 molecules are 77 AMU, like that. Next one, do everybody. You guys try quickly. Start the question. I'll give you 1 minute to solve. Less than 1 minute, quickly do. Nauman, you have to be listening to the class. Do the next question, Nauman, not a problem. I'll explain this one also. I'll explain the next one also. But instead of chatting, need to answer. Only I should see ABC in the chat. I should not see topper and talking to each other. Okay, we'll remove you from the class if you do that. Behave in the class. Okay. Syed Basha, Patan, Sweetie, whoever you are. Palam Likhita. Do not talk anything else apart from answer. Yes. C, Debandatta, B, A. Okay, all of you are giving different answers. Beta, it is milligram. Are you seeing properly? It is milligram. It is not gram. Milligram. C. Okay, many answers I have got. I am explaining for you now. Nauman. Nauman, you see here, unitary method I am explaining for you again. Those who are not clear with unitary. I want to compare ammonia's molecules versus ammonia ka mass. Molecules versus mass. I will say, what is ammonia? Ammonia is NH3. 1 mole ammonia means 17 grams, because nitrogen molar mass is 14 gram, hydrogen is 111, 17 gram. 17 gram contain Avogadro molecules. Many times I have told this part now. I hope it is clear. 17 gram contain Avogadro molecules. Unitary method. Whatever is known, you can keep it on left hand side. Mass is known. I will keep this mass on left hand side. I will keep this Na molecules on the right hand side. I will say 17 gram ammonia contain Avogadro molecules. Okay. Then 1 gram ammonia. You can use crisscross, you can use formula, you can use anything. Yes. 1 gram ammonia will contain Avogadro by 17. Avogadro by, this number goes down. Always in the unitary method, this number goes down. Na by 17 molecules. Now the mass given to you is 6.8 milli, means 6.8 into 10 power minus 3 grams ammonia will contain Na by 17 into this value, 6.8 into 10 power minus 3. These many molecules. Okay. Archana, I have just explained it. Yes. So, what are we getting here? This goes at 0.4 times. So, 0.4 into 10 power minus 3 means 0.1234 Na. Okay, 4 into 10 power minus 4, which is option C. Which is option C. C, yes, C, Lasya, Lakshmi Devi, Tanu. Is it, if it is clear to everyone, not D, C is the answer, bache. You have done it for gram. I have told you it is milligram. You have to see carefully. NEET will confuse you like this only. You will not look at the units properly. It is milligram, not gram. It is milligram, not gram. Harita, depends on the question. If Na is given, you can keep it in Na. If the full value is given, you can keep it as full value. Is it clear to everyone? Just put a thumbs up if it is clear. Then we'll move to the next one. And like the video, please. Before moving to the next question, I want 450 likes on the video. 450 people are watching right now. I need 450 likes on the video. Put a thumbs up if it is clear. And then we'll move on to the next question. Quickly. Quickly. Be fast. Be quick. Okay. Yes, next question on your screen. Calculate the number of atoms in 5600 ml of carbon dioxide at STP. Quickly. Do it. I'll give you 50 seconds. 50 seconds for this question. I'll give. Do this question. Good, good, good. Do the question. See carefully the question. Calculate the number of atoms. And the time is up. Someone says D, someone says C, someone says B, A or D. How can two answers be there? It has to be one answer. All of you carefully see here. Carefully see here. Yes, C, someone is saying C. Okay, let me see. Let me see. Let me see what is the answer. Let us check. Okay, let us check. All of you see here. Okay, Archana, see here. For Archana, I am explaining this. Okay, see here, everybody. Now don't use the formula here. You can use the formula. I'll tell you how to go by the formula as well, but I don't generally, tell by the formula. You see the unitary method, that is much better. Okay, number of atoms I am asking, not molecules. CO2 is a molecule. Each CO2 molecule has one carbon atom and two oxygen atoms, so total 3 atoms are there. So if you have found the molecules as the answer, that is not correct. You have to triple it. You have to triple it. Atoms will be triple meson. In CO2 molecule, there are 3 atoms. No, 1 carbon atom, 2 oxygen atoms. So I have to triple it. So I'll use the unitary method. I'll say CO2, 1 mole CO2. I can say, do I need the mass? I don't need the mass. No, let's not write the mass now. I'll just talk about volume. I'll just talk about molecules and atoms. Okay, 1 mole CO2 means 22.4 liter, or I can say 22400 ml CO2 at STP. This is the volume. 1 mole occupy 22400. Correct? Okay. 1 mole contain Avogadro number of molecules, not atoms. CO2 is a molecule, na beta? CO2 is a molecule, na? So 1 mole of CO2 will contain Avogadro molecules or atoms. It will contain Avogadro molecules. Yes. Now each CO2 has 3 atoms. Each molecule, 1 molecule has 3 atoms. So Avogadro molecules will have 3 Avogadro total atoms. Now our concern is to compare the atoms with volume. I will use the crisscross method. Volume and atoms. So I will say volume versus atoms. When volume is 22400, then atoms are 3 into 6 into 10 power 23 atoms. 3 Avogadro atoms are there. When volume is 5600 ml, then atoms will be X. Crisscross, cross multiply, this multiplied by this multiplied by this. So I get how much? I get 22400 times X equal to 18 into 10 power 23 into 5600. When you do 56 into 4, it is exactly 22400. So this will go 4 times. This will go 4 times. So x comes out to be 18 by 4 into 10 to the power 23. 18 by 4 into 10 ki power 23, which is how much? Which is 4.5 10 to the power 23. Is it clear to you, Archana? Is it clear to you, Archana? C is the answer. Is it clear to you? Is it clear to everyone else? Quickly tell me, quickly. Milky Vindhya will not reply to you. Is this clear to everyone? Option C, you see here, no? It is option C. Yes, okay. Yes, so most of you are saying yes. Those who are not able to understand, please watch the previous videos also. Don't start directly with this video and look at the other questions. It will be clear. Okay. Yes, okay. All right. Going to the next one, everybody. You have to keep writing along with me. You have to write before me first of all. Okay. Mahi Sudha's Kitchen. I saw your message. Okay. I'll be telling the next question. You see there. It will be clear to you. In this question, what I have done is number of atoms they are asking, volume they have given. I have written the mole concept of CO2. 1 mole CO2 means 22.4 liter. But CO2 is a molecule, not an atom, bachche. So CO2 is a molecule. 1 mole will contain Avogadro molecules. But they are asking what? Atoms. Each CO2 has triple the amount of atom. 1 carbon, 2 oxygen, 3 atoms. So Na molecules will have 3 Na atoms. Now I am comparing the volume in atoms, that's all. 22400 mein these many atoms, 5600 mein how many atoms? Answer is this. Next, all of you, practice, try. Practice makes the man and woman perfect. I will not make you perfect. You will make yourself perfect. Okay? Practice. Don't talk to each other. Practice. Do this question. Do this question. What volume of ethane gas? What is the formula of ethane? Can somebody reply in the chat? What is the formula of ethane? What is the chemical formula of ethane? What is the formula of ethane? Don't know. It is C2H6. Now do the question. C2H6 ethane. Ethane is a gas. What volume of ethane will weigh 4.8 kg? Quickly do. I am giving 50 seconds more. Exactly at 2 minutes mark, I will start telling the answer. Yes, you do. I will do this by formula. Okay, we'll do it by unitary also. Your wish. Both the methods you have. You want to do it by unitary, you do it by unitary. You do it by formula, your wish. C2H6. Yes, all of you do. All of you do. Can we remove people from the video? Can we remove them? Mr. Panda is there, you remove them. Mr. Panda. Okay, nothing, no nonsense will be tolerated in the class, as you know, everybody. Okay. You can keep the chat on, no problem. Okay, I am telling you now, see here. I am telling you by formula now, by formula. There were 3 formulas for the moles. Okay, there were 3 formulas for the moles. Here I have to compare volume formula versus weight formula. volume versus weight. Volume versus weight. Volume formula of the moles was equal to volume by 22.4 liter. Volume by 22.4 liter. And the weight formula was weight by molar mass. Weight by molar mass. This was the formula. You can do it by unitary also. Both will anyways give you the same answer. Okay, question is what volume? This is unknown, so I'll keep it as V only. 22.4 liter. Weight 4.8 kilogram means 4800 gram. 4800 gram, 4800 gram. Divide by molar mass of ethane, you can calculate its molar mass comes out to be 30. 2 carbons, each 12 gram, plus 6 gram for the hydrogen. It comes out to be 30 gram. 30 gram. Okay. This 0 cancel out. This goes exactly 160 times. So volume comes out to be from here 22.4 times 160 times 160. Okay. Yes. 3584 liter. 3584 liter. B is the answer. For Marani, I am telling the unitary method also for this question. Marani only for you. I will not tell again and again. Okay? You have to understand. Be careful in the class. Be attentive in the class. Ethane C2H6. So I'll say 1 mole C2H6 contain Avogadro molecules, weigh 30 gram, occupy 22.4 liter. Okay. If they asked us about atoms or anything, I could have said it contains 6 plus 2, total 8 atoms. So Avogadro molecules will have 8 Avogadro atoms. I could say like this also. Okay. So now our aim is to compare volume versus mass. So I'll say 30 gram is the mass and the volume is 22.4 liter. So I'll say 30 gram occupy 22.4 liter. 30 gram occupy 22.4 liter. 1 gram is going to occupy 22.4 by 30, these many liters. So 4800 gram, which is 4.8 kg, will occupy 22.4 by 30 into 4800 and you will get your answer as 3584. Which method is easy? Now you tell which method is easy. Okay, both are easy. Don't talk among yourself. Okay, just tell the answer. Is it clear to everyone? Yes or no? Quickly. One chocolate question I'll give you. Let's see how many of you answer it. Okay. So once you come back to the classes, you can come and collect your chocolate as well. One chocolate question I'm going to give. 2 minutes I'll give for that. It is little difficult one, I can say, but if you are smart enough, you will be able to do this as well. A sample of ammonium nitrate NH4NO3 contain 3.2 gram atoms I had mentioned, but I told you gram atoms are nothing but moles. It contains 3.2 moles of nitrogen, N. 3.2 moles of nitrogen. What is the mass of oxygen in this sample? What is the mass of oxygen in this sample? Then don't apply the formula, no, if you are getting confused. Do it by unitary method. Don't apply the formula. Do it by unitary method. Kumara Abhi, very good. Clap for Kumara Abhi. Clap for Asif. Yes. Now once others are answering, I don't know whether you are answering looking at their answer or you are solving them, but yes, B is correct. B is absolutely correct. You can see here, I'll just solve it. Ammonium nitrate is given to you, NH4NO3. Moles of nitrogen are given, mass of oxygen is asked. All of you see here. All of you see here. Ammonium nitrate. Let us know everything about ammonium nitrate in terms of mole concept. I will say 1 mole of this compound. I don't have to know the mass because nobody is asking the mass. No, I just have to talk about nitrogen and I have to talk about oxygen. All of you quickly see here. Can I say in 1 mole of this compound there are 2 moles of nitrogen? Yes or no? Can I say there are 2 moles of nitrogen? Yes or no? In 1 mole of this compound there are 2 moles of nitrogen. Okay, so there is 2 mole nitrogen atoms. In other terms, I could also say there are 2 gram atom nitrogen. I told you in the beginning of the class, moles can also be called as gram atom. Okay. At the same time, how much oxygen is there inside it? Inside the 1 mole of this, oxygen is 3 moles. You know, each mole of oxygen weighs 16 gram. So 3 mole will weigh 3 times 16 grams of oxygen is present inside this. I am just opening up this molecule and I am checking how much N is there, how much O is there. Nitrogens are 2, oxygens are 3. 2 nitrogen moles means 28 gram. 3 oxygen moles means 48 gram. So I have 48 grams of oxygen and 2 moles of nitrogen. Now they are asking you to compare these two things. This versus this. Unitary method, simple unitary method. So I'll say when 2 mole nitrogen is available, then oxygen is 48 gram. Okay, then oxygen is how much? 48 gram. In ammonium nitrate, there are 2 nitrogens. There are 2 nitrogens and 3 oxygens. So 2 nitrogens means 2 mole nitrogen, 3 oxygens means 48 gram oxygen. Now they are saying if nitrogen is present 3.2 moles, 3.2. So 2 mole nitrogen mein 48 gram oxygen. When 1 mole nitrogen is there, then it will be 48 by 2 gram oxygen. And when 3.2 mole nitrogen is there, oxygen will be 48 by 2 into 3.2, which is 24 times 3.2, which is in the range of 70s. In the range of 70s, 76.8 gram. It was a little difficult question. I just gave it to you to challenge you. Okay. You first make sure that other questions are clear to you. This same file will be uploaded in the description at the bottom. Okay. Do all the rest of the questions. I have brought many more questions for you. Since the time is limited, we could solve only these many. For those who are not clear with any of the concept, please rewatch this video once more because this is the most important chapter. You will be using it in almost every concept of 11th and 12th class. Okay. If it is clear to you, if it is 70% also clear to you because being a little new topic for you, then put a thumbs up in the video and I'll see you all in the next class. Okay. I'll see you all in the next class. Put a thumbs up if it is clear. Nauman, I explained 2 questions for you, Nauman. Yes. Okay, chalo. All right. All right. Bye bye. I hope you enjoyed the class. Thank you. See you all in the next class. Bye bye.